Hi, mathletes. Today we're going to use balances to find an unknown. Here's an example of a balance, and they're equal because it's balanced. And you can see that on one side I have three kites, and on the other side I have a mass of six and one kite. And so we'd say that they're equal again because it's balanced. If we wanted to use variables, we could let the letter or variable k equal the kite, and then I can rewrite it as 3k equals 6 plus k. Notice that there's no coefficient of a 1 in front of the k. It's understood, so we don't need to put a 1 in front of it. Here's another example of a balance. This time I'm using circles. So I have two circles plus a mass of 3 on the left side, and that is equal to one circle plus a mass of 4 on the left side. Again, if we wanted to use variables, we could have c equal circle and then rewrite it as 2c plus 3 equals c plus 4. And again, there is no 1 in front of the c. You do not need to put a coefficient of a 1 in front of the c. It's understood that there is one c. Now, we know that if we change one side of the scale without changing the other, it's going to become unbalanced or unequal. Therefore, we need to always change both sides of the scale in the same way to maintain the balance. I like to think of it as what you do to one side, you have to do the same thing to the other side. So with a balance that has an unknown, the goal is to determine the missing value, which we call the value of the unknown. So here we have our two scales again, the left hand with the kites and the right hand with the circles. So the one on the left, the unknown is a kite. So we want to figure out how to find the value of one kite. The one on the right, the unknown is the circle. So we want to figure out how to find the value of one circle. To find the value, we need to change both sides of the scale so that there's just one unknown object on one side of the scale. We can't have an unknown object on both the left and the right side of the scale. So let's look at this using a t-chart and pictures. So you can see that I've drawn out my first equation with the kites. I have 5 kites on the left-hand side. I have a mass of 15 and 2 kites on the right side. And remember, it's equal, it's balanced. So we're going to have to isolate one of the kites on one side of the scale. So here I have my equation. 5 kites equals 15 plus 2 kites. And again, we could say that k could equal the kite, and then I can write it using variables. 5k equals 15 plus 2k. But remember, we want to isolate so that we have all of the kites on one side of the scale. So what we'll do is we'll take away 2 kites from each side. So 1, 2 from the right side. So I need to also take away 2 from the left side. Now, all of my kites are on one side of the scale, just like this. So if I wanted to write this in my equation, I would say my 5k equals 15 plus 2k, which we read written above, and now I'm removing 2 kites or 2 k's. So I removed it from my right side, and I need to also remove it to the left side so that it stays balanced. And now I have 3k because 5k minus 2k is 3k equals 15. Again, there's my 3 kites, and there's my 15. Now, I want to figure out how much one kite is. So in order to do that, I'm going to divide each side by 3. Therefore, I only have 1 kite on the left side and 5 as a mass of 5 on the right side. So we divided each side by 3, and 3k divided by 3 is k, and 15 divided by 3 is 5. Let's look at another example. This time we're going to use x's and numbers. So I have x's and numbers on one side, and on the other side I just have numbers. And your goal is to isolate so that we just have one x on one side of the scale. The good news here is that we already have all of our x's on one side. But again, we want to get x all by itself. So there's just one x left here. So this equation is 2x's plus 2, and that's going to equal 6. 1, 2, 3, 4, 5, 6. Now we're going to remove 2 from each side. Again, I'm trying to get my x's all by themselves. So if I take 2 away from the left side, I need to take away 2 away from the right side. And now I have my 2 x's and I have 4. So 2x plus 2 equals 6 was our original equation. I'm taking away 2 from each side. So notice it's from the left side and the right side. So 2x equals, and 6 minus 2 is 4. So 2x's equals 4. But I want to know how much 1x is. So what I can do now is divide each side by 2. And if I divide each side by 2, I end up with 1x on the left side and 2 on the right side. And 2x divided by 2 is 1x, and 4 divided by 2 is 2. Let's look at another example. This time I have 3x's plus 1, and that equals 4. Again, we want to isolate, so we have just one x on one side of the scale. So this time I'm going to subtract 1 from each side. And when I do that, I end up with 3 x's on the left side and 3 1's on the right side. So we subtract 1 from each side, and I get 3x equals, and the difference between 4 and 1 is 3. Now I'm going to divide each side by 3, since I'm trying to isolate this so I just have 1x. So when I divide it by 3, I divide each side by 3, and 3x divided by 3 is 1. X and 3 divided by 3 is 1. So x equals 1. Now this one has an integer. So this time we have 2 x's on the left side and a negative 1, and an x and 2 positive x's on the right side. So we can write it as 2x plus negative 1 equals x plus 2. So what I want to do is I want to remove a negative 1 from each side. Remember, removing a negative 1 is like adding 1 to each side. The problem is that I don't have a negative 1 to remove from the right side. So I need to put in a 0 pair. So remember, a positive 1 and a negative 1 is a 0, and zeros do not change the value. So I put in my 0 pair so that I can remove the 1. So there it is. Now I can remove it. And notice I removed it from this side as well. So I have 2x plus negative 1 equals x plus 2. I'm removing my negative 1 from each side. So I end up with 2x equals x plus 3. Now I'm going to remove x from each side because I want to get all the x's on one side. So I subtract x from each side, and I end up with x equals 3. So my solution for this one is 3. Here's another example. This time I have a partial x, so I have 1/2 of an x. So I have 1/2 of an x plus 1 equals 3. Now I'm going to remove 1 from each side because remember, I want to get x all by itself. So when I subtract 1 from each side, I end up with 1/2 of an x equals 2. I subtracted 1 again from each side, and the difference between 3 and 1 is 2. Now I want to know how much a whole x is. So I'm going to multiply by the reciprocal of 1/2, because anything multiplied by the reciprocal is 1. So you can double each side, or again, multiply by 2. And now I have a full x. And when I multiply both sides, I end up with x equals the product of 2 and 2 is 4. So x equals 4. I hope this helps with your understanding on how to solve multi-step equations using a visual. Again, this is another way to explain why this works.